In this video, we'll take a look at a couple of problems from out of section 2-3, and we'll start by looking at some problems from 1 through 16. These are a few problems that just want us to find derivatives, not really asked to do anything with them, just asked to find them. Now, if you look at number 14, the function that we have here is a product of two functions of x. If you remember what we discussed in class, if you look at the screen in the notes that said that derivatives were linear operators of each other, we had nothing on that screen that involved multiplication. If you have multiplication of two functions of x, this function of x times this function of x, right now the only way that we can take this derivative successfully is if we first do a little bit of algebra. So this is not f prime, this is just an alternate representation for f. I'm going to do first times first, I'm FOILing this out. First times first will get me 3x cubed. Outer times outer will get me minus 4x. Inner times inner will get me plus 3x squared, and then last times last will get me minus 4. I no longer have a product of two functions of x. Now I just have terms separated by addition and subtraction, and what we can do once we have a polynomial, no more product, we can go ahead and we can use the power rule on each individual term. So the power rule says multiply this coefficient by that exponent. So this 3 times that 3 will get us a 9. And then we're going to take that exponent down by 1. This exponent's a 1. So if I do this coefficient, which is negative 4, times the 1, it stays as a negative 4. And if I reduce this exponent by 1, it'll become an x to the 0. But anything to the 0 power is 1. And if I put it down there, it's just kind of taking up space. So I'm not going to bother doing negative 4 times 1 because it's just negative 4. The next piece, coefficient times exponent, gets us 6. Subtract 1 from the exponent, leaves us with an x to the first. And then the derivative of a constant is 0. So here would be the derivative of the function that we started with in number 14. We had to get rid of the product first, though. We couldn't just take the derivative of this piece, and then times the derivative of this piece minus that piece. We had to get rid of the product. Number 16 is going to be similar because on that screen of notes that involved the fact that a derivative is a linear operator, nowhere did it have division. We can't do the derivative of this unless we get rid of the division first. And we can actually do this division. We have each of these three terms in the numerator being divided by the square root of x. Now, I don't want to divide them by the square root of x. I would rather see that written as a power of x. So the index on this root is a 2. If I'm converting this to a corresponding power, the index on the root is going to become the denominator of the exponent. So it's going to become an x to the 1/2. I want to divide each of these three terms by x to the 1/2. I'm just going to use division of like bases, x squared minus x to the 1/2 when I do that division. So this is not the derivative. This is still just f of x. But when I do division of like bases with these pieces, 2 minus 1/2 leaves me with 3/2. When I do it with these pieces, 1 minus 1/2 leaves me with positive 1/2 as the new power. And then the sign of that term's negative, sign of the last term's positive. If I do 3 divided by x to the 1/2, I still have a fraction, I still have division. I'm going to just think about saying this 3 divided by x to the 1/2 can be rewritten as 3 times x to the negative 1/2. So I've moved this across the fraction bar and up into the numerator with the 3, so that on this next line I can just apply the power rule for derivatives. So here's f prime of x, and if I apply the power rule for derivatives, I'm going to have 4 times 3/2. So I'll write out an extra line here. I'm going to have 4 times 3/2. I'm going to have to subtract 1 from this exponent. I'm going to have the negative 1 times 1/2. That'll give me negative 1/2. I'm going to have to subtract 1 from this exponent, and that'll be my new exponent. And then I'm going to have positive 3 times negative 1/2, which will give me a negative answer. 3 times 1/2 would be 3/2. And then I need to subtract 1 from that exponent, and it would become a negative 3/2. Just to simplify this a little bit, clean it up a little bit, we can go ahead and we can do 4 times 3/2. You know, top times top gives me a 12. Bottom times bottom gives me a 2. 12 divided by 2 would be 6. X to the 1/2, you want to change that to 6 square root of x, feel free to. If I want to, I could move this back into the denominator because of that negative exponent. Same thing here, I can move this into the denominator because of the negative exponent. I don't want to focus on the algebra so much. I want to focus more on being able to use the rules that we've developed in this section to take derivatives, as opposed to steps to simplify derivatives once we finally have one. I would definitely focus on the problems in 1 through 16 in this section. It'll get you practicing with the derivative rules that we've developed thus far.